Hi everyone, this is Rafferty, and today I'm going to talk to you about the Microsoft DevOps platform. In this video, you'll be able to see the following. I'm going to start off with an introduction of what is DevOps and what is DevSecOps, and then I'm going to show a demo of two of our tools and how they work together, namely Azure DevOps and GitHub. And then finally, I'm going to show how to expand this and basically how these two great tools integrate with Microsoft Teams and Microsoft Azure. Okay, so let's start. Be Now, before joining Microsoft and before I'm in this role as a DevOps coach, I have always been in multiple software delivery projects. A good 5 years of my life has been doing the same waterfall software methodology that you may know about, which is plan, design, you code and test, you create the build, right? And you fix the build. You actually try and deploy it to an SIT or UAT environment, and then you basically make sure that the app is working, right? After that, you finally test the deployment and then hand it over to the testing. After all the bug fixes, finally release to production. Now this is fine for maybe projects that don't have a lot of changes in between, because as you know, and one of the biggest pain points of waterfall projects is that when the requirements change, you basically have to go back to design phase, and a lot of the things it may cause a lot of impact in how you coded the application, right? So one of the this is a real metric. This is one of the biggest projects that I've worked in the past. We had this notion that when we find a change or there's a bug or some sort of change, and if that certain component is already in production, it could take us as long as 8 days uh, before we can deploy a bug fix, for example, to production. And the reason for that is whenever there is a change because of the waterfall cycle and because every step is basically manual, we have to always deploy to dev first and then to the SIT environment and then to the UAT environment. And in other projects, they even have a pre-production environment before production, right? And so that would take a long time. Now, fast forward, I have also worked with a lot of agile projects, from startups to big enterprises. And this is typically the flow, and this is using Scrum. Like we start with sprint planning, we do our our 2 to 4 week sprints. And based on the definition of done, right, we will basically employ as a Scrum team certain engineering practices such as test driven development, automated testing, of course, which is part of it, and automated deployment, right? Now, depending on the maturity of the product and maybe the company itself, we probably will only automatically deploy up to SIT and UAT, but I've seldom seen a project that automatically deploys to production, but it does happen, right? And in Microsoft, we do that a lot. Now, the other one is, of course, in a typical Scrum, right, or in a typical Agile project, we'll do a daily Scrum. Finally, we do a sprint review, and and if the product owner is happy with the potentially shippable product increment, he may say, okay, please deploy this to production. Now, this is fine as well, but the in my experience when I was managing this operations team, we also had a lot of problems with this, and mainly because um, the uh, the ops team may find it difficult to catch up to the pace of the dev team. These are the common complaints that I've seen. Like the ops team will complain, You're deploying too frequently. Did you test this properly? Our ops team is simply not prepared or not geared to so frequent deployments, and that we are now unable to support the production environment, right? Another complaint comes from the infra team. As the development team becomes faster in creating their own software, a business may come in and say, "Hey, can you try this out? Can you test this out?" And of course they could, right? Because they're quite agile. But often they will need infra to provide them with a new dev environment, with a new testing environment. And in my experience, at least in the large SIs that I work with, that typically takes 3 weeks or more just to provision a new server, for example. And so you may be agile as a dev team, but if your ops team and infra team does not catch up, then you're in trouble. And I believe this is one of the biggest reasons why the world today has kind of gravitated towards DevOps type of discussions than just purely Agile. Agile is necessary. I mean, I think it's one of the revolutionary changes when it comes to developing software. But after that, right, you need to make sure that your ops team, your infra team, everyone else are all integrated, right? All collaborative, all working together to basically deliver such a great software. Okay. Now in Microsoft, we had our fair share of transforming our company from waterfall to agile and to DevOps as well. Um, just a quick number. This is just one of the motivations. There are many motivations, but one of the motivations was, let's say, for example, back in 2018, we had 90,000 users. Okay, if we could just save a minute a user per month, just imagine how many man days, or actually, I should change this slide to effort days. Um, that we can save, right, in a year, about 187 of them, right? So that's just one of the main motivations. In the latest State of DevOps surveys and reports by these two sources at the bottom, they also highlighted a couple of things. These are the key points that I kind of pulled off from these surveys and then put them in this PowerPoint that you see here. And let me bring your attention to two of these, right? The first one is somehow we found, or the surveys found, a strong correlation between an organization's maturity in DevOps and their actual business performance. That is quite amazing, right? The more mature your company is in DevOps, the faster you're able to deploy, the faster you're able to address the market and create products and features for your customers. The next one is we found that most companies who are mature in DevOps, since they can do DevOps well, they can and then do security well. Because they're able to automate certain things in dev and test, they started expanding that capability and they start automating maybe security scans, penetration testing, or implementing security policies in the environment and maybe network hardening and all that, right? Those things now can be automated upon creation of the environment or upon every code change rather than doing all of these things at the end of the development cycle. So yeah, so those are the two highlights. This one also came from the State of DevOps report, and it shows the typical, I say, stages in a company's maturity in DevOps, right? Usually companies would start off with just standardizing or the have everyone use a normal a source control, and then let them standardize on certain engineering practices like, hey everyone, let's all change into agile. Let's start using this tool. Let's implement this kind of branching strategy. So that's kind of stage one and two. Stage three is then expanding that further from a pilot project maybe to the rest of the organization. And there are excellent frameworks there, like SAFe, the Scalable Agile Framework. And then in addition to that, right, in stage four, they started automating infrastructure with infrastructure as code, as you hear, right? And then they started providing this infra as code as a self-service portal to their maybe the business users or the new project teams. Now in stage five, right? Just imagine you are a dev team and you need to quickly try a POC, quickly try a business idea and see if it works. Now you can go to this internal portal that your company may have built, click the button, provision this set of three-tier web architecture, for example, and then start coding. Just imagine a world like that where you're able to provision the infra quickly, and you know that the infra complies with all your security policies and regulations. So what is DevOps? It's really the union of process, people, and products. If you think about these three things, really, although this session is about the product, I'd say 80–90% of the DevOps adoption is about the people and the process. And so if you need help in those areas, I advise you maybe engage an agile coach or a DevOps coach who can help you in those areas. Session today is more about products, but maybe I should read from this slide first. So people, process, and products, and then DevSecOps. Later on, I'll show you what it is really. But essentially, rather than doing all the security checks towards the end of the project, we're trying to shift that forward or shift that to the left of the cycle, and uh, do the security scans at the beginning. Okay, so like I said, people, process, and products. The people is about roles, responsibilities, and culture, which is a big area. In this part, all I can say is in Microsoft, when we started adopting, one of the biggest change we did was to stop calling our developers developers and calling our testers testers. We just called everyone engineering, including our support team, the third level escalated support team. We called them part of product engineering. And why did we do that? By just changing the title, we started, or there's this implied expectation that everyone now is cross-functional. And that's amazing because now the developers need to care about testing, need to care about what's actually happening in production, so on and so forth, right? Process is another thing. There is something called waterfall, DevOps or waterfall, and some organizations make it work, but most of the organizations do use Agile. So in this tool that I'm about to show you, we just supported both. We support if you are still doing waterfall, we support it. If you're doing agile, we support it. If you have projects doing both, we support that as well. And in agile, we know there's extreme programming, there's Scrum, there's Kanban, and you may have your own waterfall or your own agile process. Later on, I'll show you how you can potentially customize that. And finally, product, right? Now, there are many products in the world today, or not many, maybe a few. Today, I'm going to show you what we call Azure DevOps, and it comes with a SaaS or software service version in a server form. And I'm also going to show you GitHub. As you know, GitHub is the largest repository in the world. There are about 50 million developers on it to date. And it's just continually expanding. The good thing is that Azure DevOps and GitHub work together, and we can integrate both together, that you can actually use Azure DevOps for the boards, for the test plans, for the pipelines, and simultaneously use GitHub repos and GitHub actions. So that's what I'm going to show you today. Okay, now let's proceed with the demo. In this demo, I'm going to show you this company called Parts Unlimited. And Parts Unlimited is essentially an e-commerce site that sells tire parts, as you can see here. And you will see that this is currently the production website. We have a development instance, a staging instance, and all of these are deployed within Microsoft Azure. You will see here that currently it's deployed with in an app service plan with 2 deployment slots, which are the dev and staging slots. Okay, so this is the Azure DevOps that we've been talking about. What you first notice here is that you as a user can be part of multiple organizations. In this case, I'm using a demo or a trial organization called 1MTC. And here, if I click a new project, I'm able to basically choose if I want to use the legacy or the TFVC as you know it. If you have used Team Foundation Server before, this is the decentralized distribution system that that TFS is based on. And then, of course, the more popular version control system today is Git. Also, in the process, you will notice that because we designed Azure DevOps to be basically suited or usable for organizations of different types of processes and methodologies, you'll see here that you can choose between Basic, Scrum, CMMI, and Agile, right? These are the four default processes that comes out of the box. Why is Scrum so special and how is it different from Agile, right? We chose, you can choose Agile if you are using a basically a generic Agile type of methodology, or maybe an Agile methodology that you created yourself, right? Or some examples are maybe Kanban or extreme programming or other types of agile methodologies. Now, Scrum is so special because in the latest surveys, we found that 80% of the agile community today uses either pure Scrum or something that is inspired by Scrum, right? So if you think about it, out of 100% of the agile world today, 80% uses something from Scrum. So if you are using agile, chances are you will be using Scrum, right? What you also see here is that you do have the option to modify the process and create something your own, right? So this is something that someone in my team has created, and this is something that I created. For example, you might be one of those organizations who created something from Scrum, but you basically evolved and changed it to suit your context better, right? So that's the project creation experience. You also see that you can create either an open source or a private project. And so let me show you Parts Unlimited. Parts Unlimited is based on the Scrum template. It is a private project. And what you initially see here is really, it starts with a README, and then you immediately, right, you will see the dashboard. The dashboard is so critical. You will see at a glance the state of the project, right? Of course, here I kind of put everything, every metric that I feel are important in here. But in reality, right, you might create a dashboard for the managers and a dashboard for the engineers or for the Scrum team. Those may be two different dashboards, right? But in this case, I just put everything in this dashboard that you see here. And what you see is, for example, the things that are assigned to me, the number of bugs and critical bugs, and the number of unfinished work. I can see here the latest build status, right? And I could actually see here like uh, not only the build status, but the latest release status. And from here, I could actually see that the release 21 is currently deployed to freshly to production. And prior to that, it was release 19. Release 20 was never deployed to production, right? So these are a few things that you see here. There are other metrics such as user stories, test results trend, if you are using the Azure test plans, which I will discuss later. You will also see other metrics like a burnout chart of you, or if you prefer a burnout chart, you can do that as well. Okay. The other thing that you can see in this dashboard is the wiki, right? You can create your own wiki here, and you'll see that you have the integrated experience. You can put your documentation here. This one is using the Markdown format if you prefer that. And we like it as developers because with Markdown, you are able to version the basically the documentation changes more easily as compared to a PDF file or even Word document files. Okay, so before I move on, let me also show you that this dashboard is actually integrated to Microsoft Teams. Why is that important? Just imagine, right? You are in a Scrum team, you're doing your project and you have stakeholders. It's very normal to have stakeholders that say, hey, I'm gonna say maybe, hey Raf, or someone in my team, hey Sui, what is the status of the project, or right? So this is a very normal question that your business stakeholders might be asking you, okay? And and typically, what would you do if you don't have a dashboard like the one that I showed you, right? Typically, the maybe the delivery manager or the scrum master or someone, right, will set up a special meeting with the team. Hey, can we meet in the next 30 minutes? I just need to give know the the latest status so that I could revert back to the stakeholder. And that is a lot of time lost, 30 minutes time lost for the rest of the team. And more importantly, it distracts them from whatever they are working on at the moment. And that is a big problem. And so what we did here is that you can actually integrate the same dashboard within Microsoft Teams, right? You see the same dashboard experience that I showed you earlier is also available within Microsoft Teams. And that helps you in a couple of ways. Primarily, it helps the stakeholder because rather than asking someone for a status, sometimes they ask for the sake of asking, right? Because they just don't want to go to a website with a dev.azure.com, right? It feels like the URL is so much for developers, and some stakeholders don't necessarily like that. So it will be easier for them that if they have the time to chat here, right? Why don't they just simply click the tab up here and immediately they see the project status, and so they don't bother anyone and they don't distract anyone from their work, right? This is part of um, enabling your team and even your business and your stakeholders for remote work. One of the key things about working from home or working remotely when you are geographically not in the same location is that you enable as many self-service functionality and features as possible. Just by making the dashboard and the reports immediately available to your stakeholders saves up a lot of time and a lot of meetings, potential meetings, because they can just go here and see the results or see the status on their own, right? So the next thing that I am going to show you is boards. Now boards, before I start discussing what's in here, one fundamental terminology is that we call everything as a work item. A task is a work item, a bug is a work item. And generically, we just call each of these rows that you see down here as a work item, okay? So as you can expect, boards is our requirements management tool. It allows you to create multiple work items like bugs, epics, features, impediments, product backlogs, tasks, and test cases. You can create your own custom work items such as change requests or other types of work items. In the Agile template, there is also something called user story work item. For the Scrum template, it's been renamed to product backlog item. Okay, but they're essentially the same. Okay, so those are work items, and what we have done here is that first, just imagine you're in a Scrum team, right? First, you will go to boards, and this is really where the product owner will start creating their product backlog. And as you can see here, they can click for a new product backlog item, and you can kind of create the different product backlogs and put the status according to the column. As you can also expect, as you click a product backlog, you can go into the detailed description like what is the description for this product backlog and what is the acceptance criteria. Acceptance criteria is very, very important because it defines how you will test this particular user story, right? And if you are practicing something like test-driven this TDD, test-driven design, um, then you would really want to know how something is going to be tested before you even start coding it, right? So this is quite critical. The other things that you can see here is that each work item has these other tabs, right? First of all, it has the history tab. It documents every change that you did to this work item. It has a links tab and an attachments tab, right? So you can attach files to each work item if necessary. Another thing is that you can link a work item to maybe your code changes or other work items. So you will see here that this work item is actually related to this test case and related to this task, which I will explain to you a bit more later. Okay, so this one, you see, this is basically the product backlog. And what you now do is maybe during the beginning of a scrum, right? The beginning of sprint, you will do something called sprint planning. when you do sprint planning, basically each team will go, each Scrum team will meet and maybe together with their product owner. And what you see here is now I can start drag dropping. Maybe this backlog should be part of this sprint. This backlog should be part of that sprint. And that is something that you can do from this backlog view, right? Of course, realistically, you will only really project like 1, 2 sprints ahead. But yeah, you can kind of push things and optionally just put them in a future sprint just to park them in a future sprint. But yeah, the Scrum team really just needs to commit to what they want to do for that specific sprint. This backlog also has an analytics tab that gives you an idea of your average velocity, and with that it gives you some idea of how much your team is able to commit for that particular sprint. Okay, now that you have um, finish sprint planning, what do you do now? Now it's like the daily work within the sprint cycle, right? So within a sprint, what you will now do is that the team will now look at this thing called sprint backlog, and each product backlog item can now be further divided into subtasks. So this is what we call a task. As you can see, this yellow icon here, right? And really this is because not every team, not every agile team today is really cross-functional, isn't it? So there are still developers who are more used to development or to UI UX. Some will be more used to data type of work. Some will be used to maybe back-end services. Of course, our goal is that every team will be cross-functional and be able to do everything. But chances are, more often than not, there are people who are stronger in a specific area and some people stronger in other areas. So what we did here is that we just basically made Azure DevOps more flexible for different types of scenarios, whether you are cross-functional or not. And for example, here as one of the items is as a customer, I should be able to print my purchase order. And what you'll see here is I could create a subtask called create the print page, which is assigned to me. And maybe I want to create maybe update the, I don't know, database and stored procedure. For example, I don't know if this is needed, but let's say it is, right? So I could assign it to a different person. So this is basically what a sprint backlog could look like. Now, if I go to a task like this one, you will also see that because Azure Boards is integrated with all the other features like Azure Repos, we are now able to quickly see and link that for this particular print page, if I clicked here, I can go exactly to where the developer or the code change that the developer did in association to this particular requirement. So for example, if I'm doing my code reviews or if I'm investigating, I could see that, hey, this guy called Rafferty actually uh, implemented the test page, but what he associated is to throw a new exception. So this is unacceptable, right? So, but this is where you can kind of do that traceability. And this also leads us to Azure Repos. So what you will see is that on the left, I am redirected to repos, and commits is the place where I see the history. But let me talk to you about Azure Repos. Azure Repos is essentially everything that you would expect from a Git repository or a TFVC repository. In this case, since it's Git, you will expect that it has cloning. It's able to, it allows you to create multiple repositories. It has branching, it has tagging, it has forking, right? So everything that you expect from a Git repo, you will see here. Maybe the unique thing with Azure repos is when you go to the branches, you will see that we are also able to set branch policies. Now, what is a branch policy? Is essentially the rules that that you want to enforce before someone is able to make any changes to that particular branch. For example, I could require a minimum number of code reviewers before someone is able to merge through a pull request into my master branch or main branch. And if that is something that I want to do, then what I'll do here is that I will turn this on. The other one is I could check for linked work items, saying that, hey, no developer is able to change anything, do any code change, unless it is associated to something in my Azure boards. So this is also important. It ensures that developers don't just happily change something just because maybe it's quite common, right? They might anticipate that, hey, I wanna let me implement this particular module because I probably need it in the future. I see it projected in a future sprint, but that's not required in this sprint, and so they shouldn't really merge that into your master branch yet. Okay, they might park it in a different branch, in a different feature branch, but they should never put it in the same master branch. There are other types of branch policies like comment resolution if there are code reviews points that they want to resolve, and you're able to limit the merge types. You're also able to um, integrate it with Azure pipelines. And this is where you do some CI/CD, right? Before something is even merged into your main branch, maybe you want to run a CI that compiles the code and runs all your unit tests. And only if all of those validation has passed, do you allow the particular feature branch to be merged um, into your main branch. And so you can do that from here. Okay, so that is one of the unique things here. Um, yeah, and so moving on, as we have been talking about CI/CD, that is my cue to move on to Azure pipelines. Now, in Azure pipelines, as you know, there are two main concepts. One is called CI, short for continuous integration, and the second concept is CD, short for continuous delivery. How we have designed this is that, and this is more of a recommendation, but you can there are many organizations who have combined both CI and CD in a single pipeline, but usually, you would create your CIs within this thing called pipeline on the left, and you would create your CDs within this releases on the left, right? So when you do a CI, and this is one of those key maybe practices, is that when you create a CI, you're not really deploying anything yet. All you're doing is you're validating the build and you're creating that package and make that package ready for deployment. Why is that important? Because it is a common practice that you create a a build package and you use that exact same package when you deploy to dev, when you deploy to staging, and when you deploy to production. The only thing that should change are the configuration files, maybe to change the connection string and all that, but the code itself should be the same, right? There have been many cases, and you might know this as well, is when an organization would build something, deploy it in dev, and before deploying to test environment, they will take the latest code again and build it again before deploying in test. And again to production, they'll take the latest code, build it again, and deploy it in production. And the problem with that is that it's very easy for additional changes to slip into your package, changes that have not been tested, right? Because essentially you are creating a new build before deploying it in production. And so it's so likely that there might be changes in that new build that have not gone through dev and test, or that have not gone through test at least, right? And so that's very dangerous. So the practice here is that first you create the build, create the package, and that's what I'm going to show you here before you deploy anything to dev, test, or state or production. All right, so let me edit this pipeline, and I am using the classic view here just for the sake of presentation. But more and more companies today are using YAML, which is more code, right? So in this pipeline, what you see here is this is really the step-by-step instructions that you would send to a build agent on how to build, validate, and package your code, right? It starts off with this thing here called pipeline, and you get to choose whether you want a hosted or a private pipeline. What is a hosted pipeline? It is basically saying that when you run this agent, Azure DevOps will automatically create a new build server on the fly in Azure, and then do the job there, right? A private pipeline is when you want to provide your own virtual machine. Maybe you are deploying on-premise or in a different cloud, or maybe you just want to pre-install the server with your own tools. You could deploy or create a private pipeline. So here I'm using a Azure pipeline, and with Azure pipelines, I do get to choose whether I want to run on Windows, on Linux, or on Mac, right? For example, if I am building an iOS app, I might choose Mac. If I am building something in Linux, a Linux application, I might choose this, or maybe if I'm deploying to Node.js or something else, I might choose this. In this case, because it is a classic ASP.NET project, I'm using this agent specification. Okay, and so let me just walk you through step by step on what's happening here. I click Get Sources. It's getting my code from my Parts Unlimited repository. This is phase one. This is just a name, right? To group the subsequent steps. And the first thing you do, right, in a normal .NET project is that you do a NuGet restore. Remember, we're working with a plain build agent here, right? So the build agent doesn't really contain anything yet. So the first thing you want to do is get the source and do a NuGet restore to download all the dependencies. After that, yeah, let me skip this for now and I'll explain it to you later. After that, the typical path is that you would build the solution, you would test the solution, right? You run all your unit tests, and then you publish the artifact. In my building, in my solution build, I have this parameter here called package a single file. And what this will do is that when it builds the solution, it will practically put it in a zip file. And so here, when I do a publish, I'm able to publish basically the artifact, which I'm copying here. I'm copying everything to this directory called the artifact staging directory, and then I'm publishing it with an artifact name called drop. Okay, so that's what this is doing. In addition, I actually added integration with some third-party tools, right? So one thing that I did, or two things that I did here is first I integrated with Sonar Cloud. Sonar Cloud is the cloud version of SonarQube, which will do static code analysis on my code, right? So this is what this is doing. And the steps is really to prepare and then run the code analysis and then publish the results. Another tool that I integrated with is something called White Source Vault. White Source Vault then is a dependency scanning tool. It will scan all the open source libraries and dependencies that my project is dependent on. So later on, I'll show you a run, right? But before that, let me just walk you through the other features here. Variables is where you could create the variables, like if you want to make the connection string a variable, for example. Trigger is an important one. When do you want this pipeline to run? In this case, I enabled continuous integration and basically said every time there is a change in my master branch, this thing will run, right? But you could add maybe to other specific branch or even to a specific folder within that branch. You can do that. The other things that you can do is that you can actually do a schedule, run this on a schedule instead of on a trigger. And you can even say, I will run this pipeline after that other pipeline has run, right? So there are other options here. Um, the options tab is another cool thing, is that when your build fails, right? If your build fails, and it will fail, right? From time to time, when it fails, what it will do is that it will automatically link this particular build to a new work item. So it will create a new work item, right? It says here create um, a new work item, and the type is bug. You can change to a different type if you want. And what it'll do here is that whenever the build fails, it will create a new bug and assign it to the person who has requested for this build. And that saves you time, right? A bug will be automatically created. Azure DevOps will automatically notify the user, maybe in an email, or if you configured with Teams, then they will get a Teams notification. That is something that you can do from here. Okay, so now that this is done, let me now quickly show you how this looks like when we run it. So what I'm gonna do now is that I'm gonna go to my code, and this is not the best practice. By right, I should be cloning this to my local machine, changing the code, testing it and all that. But for the sake of simplicity, I am gonna change it directly from here, and also show you that something like this is possible if you allow it. Let me see here. Let me go to yeah, views, shared, and layout. Okay. So what I'm gonna do is just do something quite simple. Yeah, quite simple. So rather than parts unlimited, let me just call it the new parts unlimited. Okay. The other thing I'm doing is, if you notice, I did not turn on any branch policy. So that means I am able to uh, uh, commit directly into production, no, not into production, but into the master branch. But yeah, this is not best practice. The best practice is you will create a branch, create a feature branch, do a pull request, and merge it into master. But for the sake of demo and simplicity, I'm going to just do it this way. Okay. And what you will see here now is that if I go to pipelines, you will see that this is now triggered, right? So it is now queued. Because I am using Azure DevOps or Azure pipelines, if I click this detail here, you'll see that here is still initializing the job. What it's actually doing is that it first looks for an available agent within the Azure DevOps region. And so what Microsoft did is that they created a set of agents there that's available, and you're able to basically pick off from that, or Azure DevOps will basically get the next available one and run your agent or run your pipeline against that agent, right? And so what you'll see here is I do get a detailed view, a log of everything that's running here, right? New git restore, build solution. So it's just gonna do that. So what I'm gonna do now is I'm gonna pause the video recording, and I'm gonna resume once this is done. Okay, and now we're done. And so you see here that the report build status has passed, and this run basically took 5 minutes and 37 seconds. Okay, so let me just go back to what it looks like. This is the summary, and as you can expect, let me go back here. It basically built properly, and there are 48 warnings in my solution, which is normal. And let me go to my test cases. I see that all my test cases have passed. There are two others that have skipped, and I am expecting this in my code. So everything's okay. Now, releases. So this is a new build, and later on, as I show you releases, I actually created an automated CD, and now it's actually deploying the latest change to my dev environment. Okay, so that's what it's doing now. Code coverage is another concept, right? So as you do your test cases and your automated unit testing, one of the things that we always check is basically the coverage of your unit tests. A good number usually is about 80% or more. But yeah, depending on the organization, will have different standards, right? So here, if I download this file, because it is a Visual Studio unit test, it will download this file called, you see here, .coverage, and I need to open this file in Visual Studio to see what the results are, or what the actual code coverage is. Okay, and now extensions, as you see here, remember we integrated with SonarQube, or Sonar Cloud rather, and what you'll see here is it will show me the results of my new code, right? So my new code, there's 0 bugs because I really didn't change anything from my last run, but let me show you this, right? So Sonar Cloud or Sonar Cube will check your code, for any kind of problems in the code itself, right? So when it says bug here, it's not really a functional bug. It is a code bug. For example, in this case, is yeah, I need to add an ID or scope attribute to the th tag, which is in the HTML, and that is considered a bug within SonarQube, right? There are other rules here, like static code analysis tools could, for example, look at your hash algorithms and see, for example, if you're using SHA-128, it may consider it to be not secure anymore, and it will flag it out and tell you to update it to SHA-256, for example, right? So these are some of the functionalities of static code analysis tools, and they are quite nice because they also update themselves based on the latest trends and findings, and will inform you if something needs to be updated in your code. The other one that I'm gonna show you finally is this thing called White Source Vault build report. Remember, White Source Vault is my dependency scanning tool. And when I ran the build, what it did for me is that it looked at all the open source dependencies in my project, and it will tell me the possible vulnerabilities of that dependency. So most of these, right, as you would expect in open source, people are quite fast into fixing vulnerabilities and will release a new version. But at least from here, right, you will be informed whether or not there is a new version, there's a known vulnerability, and it will ask you to upgrade to the latest version. The other thing that I really like about White Source Vault is this thing called license risk and compliance. This is not typical of dependency scanning tools. What it does is that it looks at all the open source licenses that you actually must adhere to. Okay, so for example, in this particular project, I actually need to adhere to all these licenses: Microsoft Public, MIT, Apache 2.0, BSD3, BSD2, and so on and so forth, right? And here there are certain risk levels. So what you would want to do is that you click this, look at the details of this license once it loads, and then you send this to your legal team for them to review. So it's just taking some time to load. Let's just wait for it. And while waiting, let me just load another one, maybe an MIT license. Okay, oops, something's wrong with the website. Okay, so interestingly, at the time of making this video, this website called opensource.org is down. So, but you get the point, right? The idea is if you go to here and you look at the licenses you must adhere to, you basically need to send off all of these to your legal team and make sure that you are compliant, right? Before, if not, then it's best that you change or remove that open source dependency and look for something else that you can comply to. Okay, so that practically ends the demo for CI. What you have seen here is that we're able to continuously build, and every time someone makes a code change, it will automatically build the package, make sure it's working, run all your unit tests, run your static code analysis, and check your dependencies, and all of that just automatically happens whenever someone makes a code change. If something fails, then it will create a new bug and assign it to the developer, right? So let me move on, and I'm going to skip environments here, and I'm going to show you releases. So there are other features that I am not showing in this demo. If you want to learn more, do take a look at the Azure DevOps documentation. Okay, so now you see here that my release 22 has been triggered and the new deployment to dev is successful, right? So if I just take a look at our code here, right? So this is the staging environment and this is the dev environment. If I hit refresh, I should see, you see here that the title has now changed to the new parts unlimited, while my staging and my production are still showing parts unlimited. Okay, so that's what's happening now. Let me show you quickly what is inside this release. Okay, so let me actually click edit here. Okay, so this is a release pipeline, or what we call CD, continuous delivery pipeline. What you see on the left are all the artifacts, all the building blocks that you will need to do the workflow on the right. Yeah, and my workflow, as you can imagine, I want to deploy to dev, to staging, and production. I just added some additional things here to make it fancy, and not really to just to make it fancy, but additional steps that will that you may find useful as well, right, in this particular demo. So on the left, I added an artifact called Parts Unlimited E2E. This is based on the latest build, so I could click add here and basically get the latest build that we just created. This is the CD that we created earlier. Okay, and then I added another artifact here called security testing. Security testing is not a build, it is a repo. So if you noticed in my repos here, I actually have another Git repository that's part of the same project called security testing. And in my security testing, it basically just it contains these three files, two PowerShell scripts and one XML transformation file. Okay, so I'm going to describe that to you later. Okay, so let me go back here. What you would expect is that since we are no longer building, remember, we have the package ready. We're no longer building anything, and all we're focused on in this part is how to deploy, right? In my dev environment, one thing that we did in this demo is that before deploying, this is the main task here, Azure App Service deploy, right? This is what we would use to deploy to the Azure App Service. You could deploy to other things like you see here. There's some tasks on if you want to deploy to AWS, for example, or deploy to an Apple App Store or to other things. Recently, I just did a hack with a customer, and we were focused on deploying to a IaaS server found on premise, right? So that is possible as well. So, but in this particular demo, I am deploying to an Azure App Service. And before that, this is an optional task, but here you will see that we are practicing something called infrastructure as code. What the idea is, if all these resources in my Azure, let's say none of these exist, right? You are in a new environment, a new Azure subscription, and none of your resources have been created by anyone yet. So by utilizing infrastructure as code, in this case, I am using what we call an Azure Resource Manager template. So there are all these JSON files that are also in my repo. It will then run, and if it sees that the Azure resources like the Azure App Service, SQL Server, all of these are not yet in my Azure subscription, it will go ahead and run this and then create those resources, right? Once the resources are ready, then I will proceed on to deploying my code into the app service, and you will see this. I'm using an Azure App Service deploy, and I'm deploying with this name, and I'm deploying to the dev slot because this is a dev environment, right? You also see that some variables now are at work here, right? So if I click on variables, you will see that I actually created a few variables here just to indicate what is the resource group, what is the app service name and all that. And that will be created when I run this pipeline. Okay, so this is what it's doing when I dev. And in my staging now, it's very simple because the previous ARM template will create all the slots for my dev, staging, and production. My staging is simply to quickly deploy to the staging slot. And then my production, I have two production tasks that I created here. One is called swap and one is called fresh, right? So swap is when I do A/B or blue-green deployment between my staging and production, right? The idea is since I deployed my changes to staging and my testers have tested everything that's in staging, and my UAT, my users have also validated the build and everything else is working in staging. Rather than doing a fresh deployment to production, why don't I just do a swap and redirect or point my basically my DNS, right? My URL to the staging slot, right? So when I do that, what happens is I am basically more confident that whatever is in production now is exactly the version that has been tested. Of course, there are some details here, like when we do a swap, it will also, based on your app service configuration, it will also swap um, the connection strings, right? So it makes sure that when you swap staging to production, the code that is in production, it will still be using the production connection strings, for example, right? So this is what this is doing. I do have other tasks here, like let me just show you. Fresh production is when I don't want to do a swap. I could trigger this manually. That's why you don't see any lines here. And rollback is another one when I want to swap back, right? So because I can swap staging and production, I can swap it again. If I want to do a rollback, I just simply need to swap back with the old staging. And so yeah, that's my rollback strategy here, right? There is another one here called penetration test. So what I did here is that when my dev environment succeeds, it will deploy or it will run the pen test automatically and it'll wait for staging, right? So what I'm doing here is I'm doing an automatic penetration testing to my environment. And this is where you start to see DevSecOps practices, right? So earlier you saw that I've been doing static code analysis and dependency scanning on my code. That's in CI, and in CD now I'm automatically doing a penetration test on my code. And rather than doing all these things at the tail end of the project, I am now able to do a pen test earlier on. Okay. There are other conditions here, like in dev. If I click this, you'll see that I am deploying to dev immediately whenever there is a new change or a new build. If I click staging here, I could change it according to a schedule. Okay, so just imagine you might have a separate team of testers, and your testers probably will not appreciate their test environment changing anytime in the day, right? So what you can potentially do is you make a schedule. You can either deploy every morning or or just deploy every Monday morning, right? And so they know that for the rest of the week, there will be no changes to the test environment unless it's a manual deployment, right? So that is something you can do. Um, the other one is in my production, contrary to uh, basically a common misconception, right? Is that when you do CI/CD, you expect everything to be automatically deployed up to production. That is not true. The main or the more common practice still being done today is that even if you do a lot of CI/CD, it's still very normal to have approvers approve something. Maybe a manager or director or someone approve something before it eventually reaches production. And this could be your product owner in your Scrum team, right? So here we do have functionality to say, I will only deploy to production if these people approve. And I do have the options to say any order, meaning any it, David could approve first before me or vice versa. In sequence means I need to approve before David, and any one user means as long as any one of us approves something, approves this, it doesn't need to be both of us, then we will still deploy this to production. The other thing that I want to just quickly show here is that we could also add gates. Because Azure Pipelines is integrated to Azure boards, I could add here multiple gates like Sonar Cloud and all this. But what I did is I added the gate and I linked to the queries, right? The queries in my Azure boards here, right? And this is where I basically created a query to check if there are any existing high or critical bugs. If there's an existing high or critical bug, what I will do is that it will automatically block deployment to production. So what I'm requiring here is that needs to be there should be zero high critical bugs before we're able to deploy to production. Okay, so let me just discard the changes and then move back here. Now that we're back here, you see my penetration testing has actually succeeded now. So you see here that my dev has deployed, right? We saw that earlier. We could still see the logs, but in this case, it's just a simple set of logs. Let me go back here, and you'll see that my penetration testing has succeeded. what is my penetration testing, by the way? What I did here is I integrated with this, uh, it's called OAuth Zap Proxy, right? And let me click that and go here. Okay, so OAuth Zap Proxy. This is an open source tool that you can actually download and run it locally on your machine. What I did here is that I basically ran OS Zap in my pipeline and run it in that build agent. And with the PowerShell and all that, I basically invoked it using PowerShell. And here you will now see all the different maybe vulnerabilities based on the scan on the penetration test. And now I can immediately fix the penetration testing findings early on, right? Rather than towards the end. Okay, so that's what this is doing. And here you see that staging is not yet deployed because it is based on schedule. Okay, but what I can do here is that I can actually manually deploy this, right? Because I cannot wait until tomorrow before showing you this demo. So that's what I'm gonna do now. I'm deploying this. Okay, and I'm gonna hit the pause button again until this finishes. Okay, so now we see that it's been deployed to staging. And if I go back to here and then refresh this site, you'll see that this should have changed to the new parts unlimited, right? So it's just taking a while because it is a fresh deployment, and as you know, IAS will take some time to start up again. Okay, so while waiting for that, let me just close the other windows. Oh, there you go, right? So new parts unlimited. Okay, so we see that they're successful. Now pending approval, right? So before I approve, right, I just want to go and show you what you would do now that you've deployed to staging, right? Usually the testers will start testing. And as you know, by this point, the tester scope of testing will now be purely focused on maybe the things that are not automated because all the automated scripts have been run already during your CI. So within Azure DevOps, we have this module called test plans. Test plans is a test case management feature which allows you to write your manual test scripts, right? So in the old days, at least in my experience, when we were doing test cases, I would see the testers have a list of spreadsheets, and in the spreadsheets it basically says step one, do this, step two, do this, and all that, right? And they would copy it. The test managers will somehow compile all the spreadsheets to find out the test results or the test statistics and all that. What you can do in Azure Test Plans is first, rather than doing all of that in spreadsheets, you can now create something called test suites and test cases. And let me show you an existing test case. When you create a test case, you will now see that this is the same thing that you probably will put in an Excel file, but now you put it in this in Azure DevOps itself, right? You put the action, the step one, step two, step three, and the expected results. The nice thing of putting it in Azure DevOps is first, you will see the same summary, history, and attachments that you would expect, right? So every change here will be versioned, and you can link it to the related code change as well. And you see here by default, it can be linked to the, in this case, it is linked to this other test, right? Oh, this is linked to a product backlog item. So I know that this test case is not only addressing like the list of what is described here, but it's also directly linked to the product backlog item that my product owner has created previously. Okay, so I can now do this, and let me show you once I start running my test case. So let me run. Okay, so when I start running, you will see that this thing popped up, and what I'm gonna do now is I'm gonna um, resize this. Click here. So it says here, launch the application. I should be testing in my staging environment, right? Launch the application. Check. Click on the category. here, wheels, check. Hover over the image and then click the shop now link. Okay, check. Click add to cart. And oh no, there is an error here, right? So what will I do? I could click X. I could say error encountered. That's typical of what you see in a spreadsheet. And then what else I can do is rather than just typing this in, because we have this add-on here, I actually have the ability to capture a screenshot, right? So let me just click that, click this, and now I can do something like this. Oops, what happened? There you go. Let me do that again. Capture a screenshot like this. And now I can see I can do something like that and error after adding to cart, right? So this is quite normal. You do that and you see that the screenshot is here, okay? There are other features here that I can do. For example, I could, rather than doing this, there is a nifty feature here to capture actions as an image. So every time I click something on the web page, it actually creates a screenshot of that particular action. I could also record the entire session itself, the entire test session, right? Yeah, so these are other options that you can do from here. Now, does the tester do after this? Well, they will save and close, right? But before that, there are cases where you know that it is a bug, so you can go ahead and straight ahead and create a bug. And there are cases where you would save and close directly, right? Why would you what would be the scenario where you don't create a bug? And that is when you know there are cases where the tester will first validate, is this really a bug? Or maybe it's simply that my test case isn't updated, or maybe the requirement that have changed. I just need to check it, right? So it could be many things, right? But for example, for this one, we know definitely it is a bug because the screen basically failed, right? So I could click the create a bug, new bug when adding to cart, or I would say exception when adding to cart. You will see that down here, all my steps have been stated, right? And now I could send it, leave it as unassigned, and my bug triage team will pick that up, and I will save and close, okay? And I will save and close this as well. And I will now maximize and go back here, okay? So what now happens? So you see this is marked as failed, and if I go back to boards, okay, and just gonna do full work item, you'll see here that now a new bug has been created. Yeah, and my bug triage team cannot pick it up, right? There are a lot of advantages here because now when a tester or when a developer picks this up, the developer no longer needs to bother the tester and say, how do I reproduce this bug? The information is here already, right? These are the exact step-by-steps to reproduce the bug, and is associated to make the main requirement. For example, if the requirement has changed, there are scenarios where maybe the developer will say, hey, this is the test case is no longer updated. I actually spoke to the product owner and the requirement has changed to something different, right? So there are many scenarios. That's why it's very important that you are able to link. Now, that's what's happening here. Now, when or before I run that next pipeline, let me show you test plans a bit more. There are other things that you can see in a test plan, like progress report. This is if you have a testing center of excellence, there are normal test metrics, right? Like what is the passing rate, what is the total number of execution run, what is the passing percentage, what is the failure rate, what is my productivity per tester, and all this you can see under test plans, okay? So now going back to releases, we have just created a bug, and let's say because approver, there's still a notification to my mailbox, right, to approve something. So let me just click that, and yep, and let's say I'm gonna approve, right? Let's say I'm gonna approve even though there is a bug, and let's say my colleague approves as well. Let's click approve here. Okay, so approve. Okay, so once it is approved, you'll notice what you'll see here is that it will still check if there are 0 or high critical bugs. Oh, in this case, it actually did not trigger because I think I did not set it as a high critical, right? So I think it's a severity, a medium severity here, right? But let's say this is high, this should have not, this should have blocked the deployment, okay? So um, processing gates, delay evaluation, case evaluation in 5 minutes on 3:34. I think it should have run already if I'm not mistaken. And yeah, let me just click the pause button again and wait. Okay, now we see that the gate has been blocked, right? So what happened here is because we have a high critical bug, then this thing failed, right? So what I will now do, let's say for example that this one has been resolved, so I'm just going to mark that as resolved, state done, right? Actually, and let me just remove it because this is a fake one anyway, right? So let me just remove that and go back to releases, right? And now what I'm gonna do, I'm gonna skip this. So what this will do is that it will actually pull every 15 minutes and see if the high critical bug still exists, right? Of course, there's some configuration needs to be done here because when someone fixes the bug, essentially you have to do a new build in a new package anyway, right? So, but here it is waiting for the next one. And what I'm gonna do here is let me just go here and yeah, click that again. And I'm just gonna say ignore gate, okay? So I'm just gonna do that. And so what this will now do is it should start deploying, doing a production swap between my staging and my production, right? So because we ignored this now. Okay, so let's just wait for that to finish. Okay, so the deployment to production is successful. As we discussed earlier, this is just a swap, right? So what we now expect is that, let me just go back here and go to staging, right? And this is my production, right? So I'll just click F5 and close my dev environment, right? What you will notice are a couple of things, right? So again, what you notice now is that in my production, this is production, you see here the word new, right? So my production now has the latest changes and it's called the new parts unlimited. And the other thing that you notice is that in my staging, it now has my old code called parts unlimited without the new, right? So what happened was that my old production is now swapped with staging, and the staging that we validated and tested is now swapped with production, right? So in the event that we need to do a rollback, then it's very easy. We just need to swap this back. But at this point, developers can still continue developing in the dev environment. Users can now start using the production environment and then observe. Okay, so yeah, that kind of ends the deployment part. Now I just want to spend a bit of time talking to you about the monitoring part, right? So earlier I showed you that all of these are deployed in app services and we do have app insights here, right? So for example, if I say we still know that there is a bug here, right? So if I click this and click add to cart, then there will be an error here, right? So now what I'm going to do is I'm going to go um, to this production app insights, and then I'm gonna go to failures, right? So what I'll see here is that hey, there is a failure here, right? And I can actually see the operation, and I see here that there seems to be a problem with my shopping cart, and this is the user path and all the available telemetry that has happened in in this type of transaction, right? So the nice thing with App Insights is first I see the error message here, right? So it gives you an idea of what is the error and what is the fix, right? The other one is because I integrated my App Insights with my Azure DevOps, what you'll notice is that there is this button here called Create Work Item. And if I click that, and let me see production, let me just type it as production issue with Parts Unlimited. And so when I click OK here, and I go back into Azure DevOps and go to boards or just work items, you'll see that this new bug has now been created in my backlog. Right? So again, the bug triage team can take a look at this and assign it and maybe put it in the next sprint or treat it as a hot fix. Okay, so that now shows you the integration now from your CI/CD now deployed into production. And from production, the operations team has been managing, they can see the error and then they can easily create a new work item and assign it back to the developers when they see a production issue, right? So all of this is basically the end-to-end cycle of the delivery process. And just going back to boards here, and this is something I forgot to show you earlier. You just imagine, right? Everyone's really collaborating through Teams, right? Everyone is chatting here, telling people that there is an issue and all that. What they can do now is go to this DevOps Kanban. So just imagine during a sprint planning or sprint review, right? They could go here again, the same. Earlier I showed you the dashboard. Now I'm showing you the Azure boards within Microsoft Teams. So here you see the same Kanban and you see the bug that we just created here is now found here. And yeah, and now you can kind of task manage here. You can use this for your sprint planning. You can use this for your daily scrums, right? And every morning you will do a 15-minute stand-up meeting and you ask 3 questions. What has been done yesterday? What are you doing today? And any impediments, you can discuss them here. And as you know, in Microsoft Teams, you can click my mouse is here on the upper right corner. You see the meet button or you can schedule, right? So this is just a quick and easy way. Let's say your developers are working remotely from different locations, working from home. They can go to Teams and they can quickly press Meet Now and go into a quick huddle and tackle the issue. Okay, so that ends my demo for Parts Unlimited. And yeah, let me just go back here and go here. Okay, and go here, go here. Yep. And yep, that ends my demo for Parts Unlimited. In the last hour, we have talked a lot about Azure DevOps and a project that uses Azure DevOps only, and that's Parts Unlimited. Here, I just want to quickly talk to you about using GitHub and Azure DevOps together. Now, GitHub as you know, is the largest open source repository in the world. To date, we have 50 million developers and counting using this repo actively. It also hosts the largest or the largest open source repo in the world, right? So most of the open source libraries that you know and that you use and love are actually found in GitHub, or the source code is actually found in GitHub. And so what I'm going to show you today is in this part is to show you this Node.js project called Contoso S3. And what you will just notice is just very quickly show you that we could integrate an Azure DevOps project with GitHub. After all, both are owned by Microsoft. So when you click on the boards here, you will see that it will be linked to a development link that is found in GitHub. If I click this, you will see that you'll see Contoso Air here, and you'll see the source code here. Okay, so that is the integration experience. One thing to note is that you can still use the repo in Azure DevOps, but what I like to do is go to project settings and basically turn off repo here so that it's not visible here anymore, right? After all, we'll be using GitHub fully, okay? So why would you do something like that, right? So first of all, you have the boards here, everything is the same. You can still use the pipelines here, or you can use GitHub Actions fully, or you can use both, right? And you can use the test plans here and so on and so forth. Now, one of the main reasons for using GitHub together with Azure DevOps is mainly because of the boards in Azure DevOps and then the advanced security features that is found in GitHub. So let me talk to you about this project that we have here, right? So this is a Node.js project. As you can imagine, this can be built using a Linux hosted agent, right? But the interesting thing here is first I could go to Insights, and because GitHub has the largest open source, or most of the open source dependencies that you have are found in GitHub anyway, you can actually see the changes of those dependencies here directly, right? So for example, here I could go directly to npm stream and I could see the latest changes, and I could even see, for example, the known issues with this particular library that I am using, right? The other nice thing about GitHub is that um, it now has security features, right? So these are some of the things that used to be in Azure DevOps. We know that we used Sonar Cloud and White Source Vault, right? In GitHub, it has built-in dependency scanning, and it also has a static code analysis tool available, right? So what I did here is really just to turn on the dependencies. I think it is um, here, right? So I just turned on the dependencies here. If I go to actions, you will see that a couple of things happen. I now have this code QL, and it's been disabled because there's been no activity. So let me just enable that. But basically what this is doing is when I turned it on, it automatically created a GitHub action for me that runs my source code against code QL. And code QL is GitHub's native static code analysis tool. You could use your own preferred static code analysis tool, but it's just nice that this is built in and it comes together with GitHub Enterprise with no additional cost. Okay, so that's one. The other one is what you will notice, and this is very nice. In addition to scanning your dependencies and knowing what's happening, GitHub has something called Dependabot. Dependabot will then whenever there is a like an update, for example, Node SAS, right? It has an update from 4.944 to 4.13.1. Dependabot automatically created a feature branch, upgraded my code automatically, and then requested for a pull request to be merged into my main branch. Now, this is super convenient because if you have the CI enabled, it automatically builds, it automatically scans, automatically runs all your unit tests. Now, all I now need to do is go here, right? And then I will see here that my Dependabot has run. It upgraded my code and it's trying to do a pull request and merge. And you'll see that my GitHub actions have run. All checks have passed. My static code analysis is successful, and my build is successful, and there's been no conflict, right? So right here, I can now go and confirm the merge, and right there and there, automatically, I did not have to clone and do the upgrade myself. Dependabot automatically upgraded the code for me, and now I can see that in my source code. Um, yeah, I can now see that in my source code, the latest code has been updated. Okay, so that is the main advantage of GitHub, and you see that now you get to enjoy the nice features of Azure boards, Azure test plans, and even Azure pipelines, and at the same time are still use GitHub as the repo and still take advantage of the automatic security scans that's built into GitHub Enterprise. Now that we've seen the demo, let me just spend a bit more time expanding the conversation to what goes beyond just the tool of Azure DevOps and GitHub, but show you some of the other services within the Azure ecosystem that can help you in your DevOps journey. One of them is something called Windows Virtual Desktop, or we call it WVD. This is a virtualized service where you can potentially offer your developers who may be working from home, working remotely, maybe you're hiring freelancers from a different country, or you just don't have access to them physically, and you want to provide them with the development environment, and you want to prevent them from being able to copy files to their local machines, especially your source code, right? So WVD is one of those potential solutions. You can grant them a virtualized desktop, and it not only is able to provide your developers with the development tools that they need, but we have optimized this to work with Office 365. So the Microsoft Teams that I showed you earlier, if they need to go into a virtual call, in a video conference even, then they can use the WVD to do their work. The other one is infrastructure as code, right? So I talked about this earlier, so I will not expand more into that. Basically, the whole Azure ecosystem, all of our Azure services do support infra as code. So whatever services that you need to provision in Azure, if you have this practice and you're mature in this practice, then you can use it to provision your Azure resources. Automated testing is another one. We spoke about the automated automated testing that's part of CI. What we did not really talk to you about, or what I did not have time to speak to you about, is this thing called Visual Studio App Center, right? So Azure DevOps can extend further into VS App Center, and in VS App Center we have something called Real Device Test Cloud. And in the Real Device Test Cloud, we have over 600 phones that actual phones, not emulated phones, actual phones, where you can send your automated test scripts, run your mobile app against these phones, and see if everything's working as you expected it. Okay. Continuous security. If you deploy your services or your code into Azure, then by default, Azure Security Center will kick in and it will check basically your virtual machines, your Kubernetes cluster, and your other resources, and give you the latest security notifications and advice. App Insights, we spoke to it. I showed you a demo on this earlier, so I'll just skip this slide. Collaboration, right? So we saw teams in throughout the demo, and so yeah, very important. DevOps is not just about the tool itself, but it's really about how do you collaborate then, right? How do you collaborate with your ops? How do you collaborate with your business? How do you collaborate across the team? Okay, and finally, you could extend it further if these are not enough. You could use something called Azure Logic Apps, and with this, you can create all these different types of triggers. For example, if you want to use Logic Apps to or create some sort of notification that, I don't know, when someone creates a work item, then I want to create a new SharePoint list or something, then you could potentially extend that and do that type of automation using Azure Logic Apps. And so this is my last slide. And what you have seen here is that Azure DevOps is end-to-end. It is multi-language and platform. You can use .NET, Node.js, and any other language. You can deploy on Mac OS, on Linux, and on Windows. It's hybrid and multi-cloud. You can deploy on-prem in other clouds and Azure. It's both automated and manual. When it comes to testing, you don't have to be 100% automated test. Your practice doesn't need to be 100% automated, but you can also do manual testing with this tool, right? We support real device cloud tests, as I talked to you about. Underneath, when people authenticate, we still use Azure AD. So the same single sign-on experience, the same endpoint protection that you know about Azure AD will apply to here. right? And of course, to collaborate, we can use Microsoft Teams. And that ends my video and my presentation. I hope you enjoyed this video. If you want to learn more, do go to this website called HTTPS Azure DevOps Labs. It has a lot of step-by-step lab instructions. I do encourage you to create your free Azure DevOps account in dev.azure.com and even your free GitHub account in github.com. And yeah, you can play around with it, explore further. There's nothing like learning through hands-on. Thank you very much. Bye-bye.